Does anybody have homework questions today? We're going to be looking in section 4.7 at the fourth dimension today. The author starts out with the question, what is dimension and what questions do you have about the fourth dimension? So I'll write down the questions that you have. I'd like you to get in groups of 3 or 4 and think about 2 questions each group of you has about the fourth dimension, okay? So 2 questions for each group in groups of 3 or 4. And then we'll write those down together, and hopefully by the end of the section we'll answer those. So I'll come around and help you get in a group if you're not in a group.
What if your question's already on it? That's my question.
Then you need one more. You can write that one down and one more. Okay, so
fourth dimension.
So yes, on the fourth dimension. What are your questions about the fourth dimension? So are you 4 working together? You're working with us? Okay, so 3 over there, and then can you 2 turn around and work with the person behind you?
When I think about 40, I think of like that Disney ride where like they spring up like I have no idea what the fourth dimension is.
I don't
know what we're talking about.
And then can you please turn around and work with me?
I don't understand what it is. I tried to look up the math and I'm still confused.
Oh, you can work with your group like that.
We came up with like 4 that were Disney World ride, which is great water.
So Disney does 4D? Okay, so that could be part of it.
We should just go to Disney World.
Deal. Deal, Trap. Did your group come up with your questions?
Yeah, well, kind of. Yeah, what is the fourth dimension?
Why? If they're like this, I just really just I like
What is it all about?
it's okay.
So that's what? One more.
I guess we could one.
We're thinking of one right now. You guys got anything?
Oh my god, I love your shoes. Thank you. How's the fourth dimension? Well, it's like, is that hat, is that 3D or is that 4D? That's 4D. That's a good question. Also, the most nice ring. That hat is 3D. But when I feel like 40, it's like I can feel it. You know what's that like? The hat's like this. Oh, I don't like that. says it's a tesseract.
So I'll get one question from each group, and then if there's still some that are missed, because sometimes groups duplicate each other's questions, so I'll get one from each group, and then if there's still some missed, we'll write those down also. Who wants to go first? What group wants to go first? Okay, what did you have?
Is it a shape?
Is the fourth dimension a shape? Okay. How about your group? What did your group have?
Where's the fourth dimension used?
How is the fourth dimension used? Okay. How about your group?
What does it look like?
What does it look like? Okay, how about your group?
Why is it harder to draw things in the fourth dimension?
Why is it harder to draw things? Why is it harder to draw things in the fourth dimension? Okay, so you're doing very well here, and what did you have?
What is it all about?
What is it all about? Okay, and let's see, you were with that group, right? Okay. What about your, you gave me the first question, didn't
Yes,
you?
ma'am.
Okay. So who has some questions that aren't on here yet? We'll write those down also. So you're all supposed to come up with 2 questions. Who came up with another question? Did your group have a second one? A second question? That was it? Okay. Did your group have a second question?
I mean, we have like, what is the fourth dimension, but.
What is the fourth dimension? Okay. Okay. And did you have another question in your group?
They just said it.
You said it? Okay.
They
You
said
it. That's usually the one that gets asked first. That's why I asked you all for 2 questions. Okay. Very good. So I'm going to put this, I have several classes, so I'm going to put the time this one meets on here and set this away until the end of the section, and we'll make sure we come back to it. Sometimes students ask for one of their questions, is there a fourth dimension? So that's the question I'm going to answer first. Current theories of the universe do say there are multiple higher dimensions, including the fourth dimension, and there's been some studies in some experiments looking for evidence that we can see in the 3 dimensions that we inhabit that would indicate the fourth dimension. So this is an article from nypost.com, January 2018. So our world exists in 3 spatial dimensions as well as the dimension of time, but that's not something you can see. What these newest studies are looking for is the effects of a 4th spatial dimension that can be detected within our 3-dimensional world. We'd have no idea what it looks like or what kind of reality the 4th dimension would offer, but it does exist in the hidden. But if it does exist in the hidden background of our 3-dimensional existence, science might be able to prove that it's there. In one of the experiments, science studied the behavior of light particles moving through specially made glass that bounces light back and forth between its edges. By simulating the effects of an electrical charge via physical input, the team observed how the light behaved, watching for irregularities that could only be made possible if a 4th dimension was working behind the scenes. The other experiment used supercooled atoms held in place on a grid made of lasers. Scientists call this setup a charge pump, and they use it to test the flow of an electrical charge while monitoring how the atoms respond. Both of the experiments yielded results that suggest that a fourth dimension really is all around us, even if we can't see it. Science isn't any closer to tapping into this hidden dimension, but knowing that it's there is an important step toward painting a more complete picture of physics, and you can bet these won't be the last experiments that toy with this idea. The life lesson in this section is, instead of trying to answer a question that appears too difficult, it is always wise to step back and try to address an easier but related question. So we start looking at the fourth dimension by getting a thorough understanding of the three dimensions that are easily accessible to us. Well, first we need a definition. So we're not going to have a formal definition until a later section. Right now we'll have an informal definition. So informally, degrees of spatial freedom of movement or how many pieces of information to locate a position. Or how many pieces of information to locate a position. So we can get a feel for what we mean by dimension with these informal descriptions. Well, we'll start with 0 dimensions and work our way up. So 0 dimensions would have 0 degrees of spatial freedom of movement, 0 pieces of information to locate a position. That's because 0 dimensions is just a point. There is no freedom of movement. There is no information necessary to tell where you're at, because if you live in 0 dimensions, that's it. There's the point, that's it. 1 dimension, on the other hand.
Wait, so it's no freedom of movement is what else?
So 0 degrees of spatial freedom of movement and 0 pieces of information to locate a position. One dimension will be 1 degree of spatial freedom of movement. So say horizontal. So you can move horizontally. In fact, 1 dimension we can picture as a line. And on your line, you only need an address to tell where you're at that on that line. If we label the line like we label the number line, then you just need 1 piece of information to tell where you're at on that line. So 1 dimension can be pictured as a line.
So is there any spatial freedom of movement?
1 degree, horizontal. So the spatial freedom of movement that you have there is just one direction, just horizontal. Yep. Or you could have done vertical, one or the other.
But what if it was like a zigzag line?
A zigzag line. So a zigzag line, you have to follow the line. You can't get off the line. If you live in 1 dimension on that line, you have to stay on it. So it'd be like an ant on the line. You can only go forward and backward on the line. So just 2 dimensions, then we would add horizontal and vertical. So 2 dimensions, we think of a plane. And 2 pieces of information to locate your position. Say 1 unit to the right and 2 up. Okay, so you have vertical and horizontal. Vertical and horizontal movement there. Three dimensions, we add one more direction. So we have vertical and horizontal, and now we want to add up. Okay, so up coming out of the plane. Now I'm drawing three dimensions on a 2-dimensional piece of paper, so I have some limitations. I have to draw up coming out of the plane as a angled line, but really I mean perpendicular, 90 degrees perpendicular to the 2 lines that I already have there. So we have vertical, horizontal, and up. 3 directions that we can move, and to identify a location in 3 dimensions or space. Space is where we live. Okay. To identify to identify a point in 3 dimensions, you would need 3 pieces of information. So how much to the right, how much up vertically, and how far do you come out of the paper? So go right 1, up 2, and out of the paper 3 units. So 3 dimensions space is where we live. Now notice how we've been adding a direction. We keep adding a direction perpendicular to the directions we already have. So the line was horizontal. The plane had vertical and horizontal, 90 degrees. Space had vertical and horizontal, and then 90 degrees to both of those coming up out of the paper. So the 4th dimension would add another direction perpendicular to the other 3 somehow. A 4th dimension perpendicular to the other 3 somehow.
Is everything in R1 like 40?
So we inhabit 3 dimensions. We don't have ready access to a 4th direction that's perpendicular. So the theory is that there is a 4th dimension about us, but it's not easily accessible. But we're going to try and learn by analogy what it's like.
I'm so confused.
Let's see. Let me finish writing this and then we'll talk. So this marker, how many dimensions is the marker?
3.
3, yeah. It has length, width, and thickness. 3 dimensions, length, width, and thickness. Okay.
Like a piece of paper.
Good. What about the piece of paper? What does the piece of paper have? 2. Yeah. It has no thickness. Well, it has the tiniest bit of thickness, but if you can ignore that, then it's 2 dimensions.
Okay, so like we're ignoring.
we ignore the thickness of the paper.
What if it was like a notebook, so like it did have?
That's good. If you stack up a whole bunch of paper, you get something that's 3D. So you get your book, your textbook.
So can we like see 4D?
So we can't easily, here's my book picked up. So the experiments that I was showing you at the beginning of the class were trying to make some of the 4D visible to us. Okay? I can't show you 4D, but I can show you the way that one dimension moves to the other, and we can see how the fourth dimension would act. So we can see how it acts from the way the other dimensions are acting as we build up dimensions. So you have good questions. Any other questions? All right. Well, let's see what objects exist in 2 dimensions. What objects exist in 2 dimensions? In other words, in the plane. So if your piece of paper is a plane, what can exist in that plane?
A triangle.
A triangle. Yes, a triangle can exist in there. Good. Triangle. A square. A square can exist. Good. A circle. So things that you can draw. Things that you can draw that don't have thickness. We're going to look at the boundaries of 2-dimensional objects. What was the boundary of the square? How did we form the square, or the circle, or the triangle? With lines. Yeah, the boundaries of the 2D objects are lines, which are 1 dimension. So the boundaries of 2-dimensional objects are lines, which are 1 dimension.
So then how does like the square become 2 dimensions if it's made out of 1-dimensional things?
So the square itself,
Oh, because it's like a, yeah.
and the square doesn't pour out to become some other shape because it's bounded by these lines enclosing it.
Because like, you could also like, kind of like you said, like in the plane it's almost looks like a graph, like you
That's right. You can find different points in the square that go in 2 different directions for 2 freedom of movements. If I'm in the square, I can go left and right, up or down. Okay. Here's a 3D object again. So here's a 3D object. It's a ping pong ball. What is its boundary? What is the boundary of the ping pong ball? It is plastic, yes. Yes, and it's so if I cut along the ping pong ball is not solid, so it's easier to think of it just collapsing and seeing its shape. So if I cut this, if I was able to do the same thing with my marker, I could peel off the edge Or here I have an apple. So the boundary of the apple or the marker or the ping pong ball, they're all just a molecule thick, right?
Sure.
How about you? Look at each other. Your boundaries. Your boundaries cover you. They hold you in. They're your skin. Your skin is your boundary. It covers you. If I peel the apple to remove its boundary, I could lay it flat, couldn't I? Because its boundary is what dimension? What is the boundary of the apple? What dimension? So the whole apple itself is 3 dimensions, but its boundary, its skin, is 2 dimensions. So your skin covering your face, your whole person that you see when you look at each other, that's just 2 dimensions. Now it might be pushed up into a nose or recessed into a smile, but it's 2 dimensions. Maybe it's easiest to see on a line. Look at a one-dimensional line.
Can you pull it down?
Thank you.
So is a square 2D but a cube 3D?
Yes. So we're going to look at the, good, yeah, we're going to look at those. Very good. A one-dimensional line. Okay, so here's a line. Boundary would be, what is the boundary on the line? What keeps,
It's horizontal.
it's horizontal, so it's one direction, so it's one-dimensional. And what do I have at the end here and at the end there? What's boundaries? Yeah, points. Which are 0 dimensions. So we looked at 1 dimensions, 2 dimensions, and 3 dimensions boundaries.
What do you mean by boundary?
So the end. So the end.
So what's like the end of the ping pong?
So the 3-dimensional boundary is a thin layer of plastic, which if I was to unfold it, like it's easier to see with an apple. If I was to take the skin off, I could lay that flat and it would be a 2-dimensional plane. We'll do it, you know what, let's do this with cubes. But
Yes.
let's do this with cubes, that will be easier. Okay. And actually, I do ask you to draw cubes in 0 dimensions, 1 dimensions, 2 dimensions, 3 dimensions, and 4 dimensions on your quiz. It's hard to ask things about 4 dimensions, but this is something I can ask you.
Square.
And eventually we'll get to drawing a cube in 4 dimensions. We'll do that on Monday though. Okay, so 0 dimensions, your cube degenerates because 0 dimensions only is a point. So your cube degenerates to just a point. In 1 dimension, your cube again struggles for form, right? It's restricted to a line, and so that's all you see out of your cube is that one line in the first dimension. In 2 dimensions, what would your cube be? Yes, good. In 2 dimensions, your cube is a square. In 3 dimension, you have the cube as you usually think of it. Now, some of you don't know how to draw cubes, so I would like for you to please learn how to draw cubes so you can get credit for this on your quiz. So draw 2 squares. Draw 2 squares And a straight edge is nice. So to draw your cube in 3 dimensions, again, we're limited because we're trying to draw an object that has thickness on a flat piece of paper. But you can draw the 2 squares and connect the squares at the corners, and that indicates your cube. So let's look at the boundaries on our different cubes in the different dimensions. So the boundaries on the 1-dimensional cube are the ends. What is at the end of your line? Points. There's a point. There's a point here at the end, a point right here, and a point right here. So 2 points which are 0 dimensions. That's what makes your line stop. It comes to a point. How about on your square? What are the boundaries of your square? Yeah. So you have a line here, a line here, a line here, and a line there. Okay. That's what keeps your square from spilling out and being a circle or a blob or a ink spot. 4 lines. The lines are each 1 dimension. Now you have your cube in 3 dimensions. So the boundaries of your cube are these faces, right? Each of these faces is a square. So you have one on the right, one on the left, one on the top, one on the bottom, one in the front, and one in the back. How many boundary squares altogether?
6.
Yeah, 6. And those squares are each 2 dimensions. So we're learning by analogy here.
2, 4, 6.
The 4th dimensional cube,
Would be
it's actually called a hypercube. Yes, good. The hypercube is what we call a 4th dimensional cube. Its boundary is 8. And what shape? Cubes. Yeah. 8 cubes. 3 dimensions. So we'll be looking at that 4th dimensional cube, the hypercube. On Monday, we'll look at how to draw that, and we'll look at some layouts of it. Right now, what I'd like to do is tell you a story. This is a story called Flatland.
Yes. We haven't done class activity.
The in-class activity we'll get to on Monday instead, so I'm going to change the due date on that, okay? So this is Flatland, written by Abbott in 1884. You can read this for free on the Gutenberg Project. The Gutenberg Project, who knows what the Gutenberg Project does? The Gutenberg Project prints out of books that are no longer copyrighted and makes them accessible for free. So you can go up to a link on the Canvas homepage for this class that links you to Gutenberg, where you can print off his book. It's only about 100 pages, and it's an easy read, easier than some of the Victorian books that have so much verbiage in it. It moves along quickly, and I encourage you to read it to learn more about fourth dimension. So I'm going to give you the Cliff Notes version. In Flatland, the homes are all pentagons, and their doors all face south. So here's the home of our main character, Grandpa Square. In Flatland, everybody's a polygon. The more regular polygon you are, the better. In fact, rank is determined by how many sides you have. So this poor line is at the lowest rung of all. Then come the triangles with 3 sides, squares. Hexagon is more prestige than the square. And as you get more and more sides in your regular polygon, you approach the shape of a circle. So circles have the highest rank. Now, everybody, can you please take out a coin? Because I'd like you to get a view of what Flatlanders see. So if you could please take out a coin, a quarter, nickel, dime, penny. Okay, so once you have your coin, everybody stand up. Oh, if you don't have this coin, you can stand up anyway. Feel good, stretch. Okay. And what we're going to do is you're going to put your eyes on level with your coin. So set the coin on the edge of your desk. And you know what? If you don't have a coin, you can put your Visa out or your student ID. Okay, your Visa or your student ID if you don't have a coin. And then put your eyes on level with your coin or your ID. Okay? I want to hear what you see when your eyes are on level. What do you see when your eyes are on level with that coin? What shape do you see? A line. Yeah, you just see a line. It doesn't matter that the coin's round. When your eyes are on level with it, you see a line. Just like if I hold it like this, you just see a line. Well, that's how Flatlanders see one another. So they just see each other. They're trapped in this 2 dimensions. They don't have a third dimension. They have no thickness. So you'll have to ignore the thickness of the paper. They have no thickness at all. They're trapped in 2 dimensions. So they see each other as a line, and they do have a faint glow at one of their vertices. So one of their corners is their eye, and that's where they have a little bit of a glow. When Flatlanders see one another, they don't say, "I see you," because they just see everybody as a line. Flatlanders approach one another and say, "Can I feel you?" So they courteously ask one another, "Can I feel you?" because they can't see each other except as a line. So they're trained from a young age to be able to feel, "Oh, you have no corners. You're my friend circle. You have a 60-degree angle. You're my friend equilateral triangle. You have a 90-degree angle. You're the square." So that's how they see each other. In fact, the reason the lines are at the lowest rung of all is because what does the triangle see when it looks at the line? Yeah, the triangle just sees a point. So lines being on the lowest rung, they have to go through Flatland waggling like this so that they have thickness and everybody can see them and not impale themselves by running into them. Well, our story is about Grandpa Square talking to his grandson Hexagon, and I'll read you a little bit from Flatland itself. So here's Grandpa Square meditating. He says, "I was in rapt thought, pondering in my mind some words that had casually issued from the mouth of my youngest grandson, a most promising young hexagon of unusual brilliance and perfect angularity. His uncles and I had been giving him his usual practical lessons in sight recognition, turning ourselves upon our centers, now rapidly and now more slowly, and questioning him as to our positions. And his answers had been so satisfactory that I had been induced to reward him by giving him a few hints in arithmetic as applied to geometry. Isn't that how your grandparents reward you? A few hints of arithmetic applied to geometry?
Yes.
Taking 9 squares, each an inch in every way, I had put them together so that to make one large square with a side of 3 inches. And I had hence proved to my little grandson that, though it is impossible for us to see inside of the square, yet we might ascertain the number of square inches in a square by simply squaring the number of inches on the side. And thus, said I, we know that 3 squared, or 9, represents the number of square inches in a square whose side is 3 inches long. My little hexagon meditated on this a while and then said to me, but you have been teaching me to raise numbers to the 3rd power. I suppose 3 cubed must mean something in geometry. What does it mean? Nothing at all, replied I. Not at least in geometry, for geometry has only 2 dimensions. And then I began to show the boy how a point by moving through a length of 3 inches makes a line of 3 inches, which may be represented by 3, and how a line of 3 inches moving parallel to itself through a length of 3 inches makes a square of 3 inches every way, which may be represented by 3 squared. Upon this, my grandson, again returning to his former suggestion, took me up rather suddenly and exclaimed, well then, if a point by moving 3 inches makes a line of 3 inches, represented by 3, and if a straight line of 3 inches moving parallel to itself makes a square of 3 inches every way, represented by 3 squared, it must be that the square of 3 inches every way, moving somehow parallel to itself, but I don't see how, must make something else, but I don't see what, by 3 inches every way. And this must be represented by 3 cubed. Go to bed, I said, a little ruffled by this interruption. If you would talk less nonsense, you would remember more sense. So Hexagon got sent away. Well, unknown to Grandpa Square, there was a listener through all this. Sphere, who did live in the 3rd dimension, was listening and overheard this whole thing. He told Grandpa Square, your grandson is right, there is a 3rd dimension. Grandpa Square looked around. What? What? What do I hear? I must have eaten too much pepperoni. No, no, says the Sphere. I'm telling you, your grandson's right. Grandpa Square said, show yourself. Where are you? And Sphere said, I'm right here. Where? Said Grandpa Square. I see nothing. Well, Sphere became impatient, so he reached into Grandpa's safe. This is Grandpa's safe. And he pulled out a gold coin and he dropped it in front of Grandpa Square. What? Said Grandpa Square. This gold appeared from nowhere in front of me. It looks like my gold. Let's see. Is it my gold? So he opened his safe up and looked, and sure enough, one of his golds was no longer in there. Now Grandpa Square knew something was going on. So he said, show yourself, show yourself. Well, Sphere settled on the plane. What did Grandpa Square see when Sphere settled on the plane? What does Grandpa Square see? A dot. Yeah, he just sees a dot. He just sees a point. So he's not much impressed. Well, Sphere could see that Grandpa Square wasn't much impressed by a point. So he continued to pass through the plane until he'd passed all the way through. So what did Grandpa Square see as Sphere passed all the way through the plane slowly? It was a line, right? A point that grew to a line that grew wider and wider and then grew narrow and narrower. Well, Grandpa Square had never seen anything like this. So he asked the Sphere, can I feel you? And the Sphere sighed and said yes, and he passed through the plane again. So this time, Grandpa Square felt the Sphere passing through the plane, and he said, oh, I'm amazed. You grew from a point to a circle to a large circle, and then you shrunk again to a point. You are a circle of circles. You are a god. And the Sphere said, no, I'm not a god. Here, let me show you. So he picked up Grandpa Square and showed him. He said, look, there's not just north, south, east, and west. There's not just two dimensions, there's a third. There's up. There's north, south, east, and west, and up. And Grandpa Square was amazed. He said, look, I can see inside my house. I can see inside my safe. I can see outside my house. I can see all my friends. Let me down. I must tell my friends there's not just north, south, east, and west. There's up. So Sphere said, yes, you tell your friends. So Grandpa Square went to tell his friends there's not just north, south, east, west, and up. And they were excited. They said, oh, that's exciting. Show me. And he's like, well, it's up. And they're like, okay, well, what is that? Well, it's not north or south or east or west. It's up. And they said, nah, you're just losing it. No, really, said Grandpa Square, there's up. Well, he couldn't convince them. In fact, they thought he was crazy, and they carried him away to an insane asylum where he spent the rest of his days mumbling, up, not north, up. So it didn't end well. But we're going to explore the fourth dimension, hopefully without anyone believing we're crazy. Okay, and we'll look at that more on Monday. Have a good weekend.